Hello, welcome to lecture 2. Today I am going to talk about triangles and some axioms and theorem related to triangles. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and the details are given below. So today I am going to talk about triangles. What are triangles? Triangles are it has three sides, is also a polygon. It has three sides, side 1, 2 and side 3, and it has three angles. Okay, I denote as alpha, beta, gamma. So this is an acute angle triangle. All angles are less than 90. And this is an obtuse angle triangle. This alpha is greater than 90. So one can compare two triangles and they can be either congruent. I will say what congruence means. This is a symbol denotes congruency of two triangles. Or the triangles can be similar. Okay, the two triangles can be similar, and this is the notation for the similar. So this is a short form for writing the whole thing. So congruent triangles, two triangles are said to be congruent or same congruent if all the three corresponding sides and all the three corresponding angles of both the triangles are equal in measure. So if all the sides are equal and all the angles are equal, then they are said to be congruent. Those two triangles are said to be congruent to each other. What are similar triangles? Two triangles are said to be similar if their corresponding angles are congruent. Angles are same and the corresponding sides are in proportion, but the sides can be of different length or different measure. Okay. Example, this is a congruent. Suppose I have a right angle triangle. I will define what right angle triangle is. This is 90 degrees. These are called right angle triangle. And this is a reflection of that. And you see this side, like triangle ABM and ACM, they are congruent because this side is equal to this side. This side is equal to this side. This is a common side. So all sides, the corresponding sides are all equal. And angle also equal. This angle is equal to this angle. This is 90 degree, denoted as some square rectangle. And this angle is also equal to this angle. So this is congruent. And similar triangles are, these are similar. As suppose I draw a triangle and this is a big triangle ABC, and I make a small triangle here by drawing this parallel to this one. Okay. Then this triangle ABC prime, the small triangle, is similar to the big triangle ABC. Okay. Because in this case all angles are same. This is common angle for triangle ABC and B prime C prime. This angle is equal to this angle and this angle is equal to this angle. So these are similar, but angles are all same. Okay, but sides are different. This side is big, this side is small. AB prime is small, AB is big. Okay, and they are in certain ratios which I will come soon. So there are some checklist or I've tabulated here test for congruence and similarity. So what are the tests for congruence? If all the sides, three sides of a triangle have three sides and three angles. So if all the sides are same, all pairs of corresponding sides are equal. Say this is a triangle. If this A is equal to A prime, B is equal to B prime, and C equal to C prime. This notation one means these are both same. This double dash side and double dash sides both are same. Triple dash side and this side triple dash side, C equal to C prime. Then they are called congruent triangle. Okay, we will prove all this. Similarly, for similarities, again you can have side, but here sides are, this is a small triangle, this is a big triangle, as I have shown earlier. So this side A and A prime, this A prime will be some factor of A. Okay, this is some quotient here, some constant here, and this A prime is equal to Q times A, B prime is also Q times B, and C prime is also Q. This is a common factor, this is a constant. So then these triangles are said to be similar. Then you have side angle side. You can have side angle side for congruency as also for similarity. So what is the difference? In congruency, two pair of corresponding sides are equal and included angles are equal. So two corresponding sides, this A equal to A prime, B equal to B prime, they has to be same, A equal to, and theta equal to theta prime. If they are same, this is side, angle, side. A is a side, theta is an angle, B is a side. So that's why side, angle, side. But if the corresponding this pair sides are in some ratio, that is, I have drawn here one small triangle, one big triangle. Angles are same. This angle here, theta is equal to theta prime. Okay. But these are in same ratio. That is, A prime is equal to some constant time A and B prime is some constant time B. And theta is equal to theta prime. Okay. The included angle has to be equal, but the sides can be of a different ratio. Then you say the triangle is similar. See, this is similar. They are not exactly same. Now, this is small, this is big, but they are similar looking. But these are exactly same, okay, looking. Same size, everything is same. So they are congruent. Similar means they are not exactly same size, but they are same looking. Similarly, you have third is angle, side, angle. So this is, suppose you have a triangle, this is angle, and this is a side. So that's why angle, side, angle. The side is included between these two angles. So if two triangles have similar angle, this angle is equal to this angle is equal to, and this side is equal to this side, then they are said to be congruent. So angle, side, angle. Two pairs of corresponding angles are equal. Two pairs of corresponding, these two corresponding angles are same. And one pair of corresponding side is equal. This is exactly same. Okay. And in similarity, instead of angle, side, angle, you have angle, angle, angle. So my angles can be same. This is small triangle and this is a big triangle. Angles are same, but sides are of a different, some constant ratio factor. Okay. This side is, this big side is this side into some constant. So this is angle, angle, angle. Okay. And you have in congruence again angle, angle, side also. Okay. So in angle, angle, side, I have just blown it up here. Suppose this is one angle given and this one angle is given here and one side is given. So angle, angle, side. If I join this here, then I know that this is alpha plus beta plus this angle should be 180. Okay. This alpha plus beta plus this angle should be 180. So this angle will be what? 180 minus alpha plus beta. Okay. So now you get this because you know alpha, you know beta is given to you. So now you know what should be this one. So now you can say this is, now you convert this angle, angle, side to angle, side, angle. Okay. So if angle, side, angle is same of the two triangle, then you say angle, angle, side, there is also congruent rule. Then the fourth one is in a right angle triangle, this is right angle triangle, if hypotenuse and one of its sides, if this hypotenuse and one of its sides of the two triangle are same, then they are called congruent. What is a right angle triangle? This is I have shown here. This is a right angle triangle. Okay. This angle between this side and this side is 90 degree. And suppose this is I call angle theta suspended by this hypotenuse. This is the hypotenuse. Then this side is generally called opposite side. We will see all this when we come to trigonometry. This angle theta is adjacent to this angle theta and this is the hypotenuse of a right angle triangle. So in a right angle triangle, the hypotenuse and one of the other pair of sides are equal. So if hypotenuse and the other side of both the triangles are same for a right angle triangle, then it's a congruent. Okay. But I can have in a right angle triangle the hypotenuse and one other pair sides are in the same ratio. Suppose this hypotenuse, I can again make it a small triangle and a big triangle. And if they are in same ratio, this hypotenuse and the side, then they are similar. For congruent, they have to be same. For triangle 1 and triangle 2, this base or one of the side or the opposite side, one of the side should be same, exactly same as the other one. And hypotenuse also has to be same, then they are congruent. And if they are in same ratio, then they are similar triangle. Okay. So how many types of triangle are there? I can classify triangles by their sides. First one is equilateral triangle, that is all sides are same, exactly same, they are congruent. This. All sides are same. Congruent means same. Okay. So they are equilateral triangle, or it is an isosceles triangle, that is two sides are same. This. When I marked one dash and this one dash, that these are two same. And this is different, is a double dash, that's why. So for this is called isosceles triangle. Two sides, three sides same, two sides same, none of the sides same. Okay. This side, this side, this side, they are all different. They are called scalene triangle. You can classify the triangle by angles. Here we classify it by sides. We can classify by angles. So this is an acute angle. All angles are less than 90 degree are called acute. If one of the angle is more than 90, then it is called obtuse angle. One angle is greater than 90. Or if one of the angle is perpendicular 90 degree, that is called a right angle triangle. So there are three types depending on sides. There are another three types depending on the angles. So acute angle less than 90 degree, and the obtuse angles are angles more than 90 degree. Now this triangle, I know that these are the sides. Okay, scalene, none of the side equal, two sides equal, all the sides are equal. Side, and this is angle, acute angle less than 90 degree angle, all the angles are less than 90 degree. This is right angle, one angle is 90 degree, and obtuse is one of the angle is more than 90 degree. So if I can have acute scalene, I can have similarly acute isosceles, I can have acute equilateral, I can have right scalene, right angle, but none of the sides are same or different. I can have right angle triangle with isosceles, two sides are same and right angle, but I cannot have right angle equilateral, because how you can have equilateral, because it is 60 60 60 I said for the equilateral triangle inside, so you cannot have this. Similarly for obtuse also you cannot have obtuse and equilateral. Okay, more than 90 degree, then one of the length will be greater than the other two sides, so you cannot have obtuse equilateral also. So there are how many types of triangles? 1 2 3 4 5 6 7. So there are 7 types of triangles. Okay, now we talk about triangle equality. What triangle inequality says that given any triangle, say this side is C, this one of the side, this C is always less than sum of the other two sides, A plus B. So this always C is always less than A plus B, or you can say that A plus B is greater than C. Okay, so it is same thing. C is less than A plus B means A plus B is greater. This open signs means greater side and closed side is a smaller side. Okay, so now if I bring this closer, this point closer, say here, again it is this condition, this holds. If I bring it very close, still it will hold. And if I almost, this point falls on this line C, this is C will be equal, approximately equal to A plus B. So C is less than or equal to, approximately equal to. The triangle inequality states that for any triangle, the sum of length of any two sides must be greater than or equal to the length of the remaining side. Okay. So A plus B is greater than C. Here A plus B is greater than C. And also B plus C is greater than A. I can add that C is greater than, if I subtract minus B and minus B, so C is greater than A minus B, or it can be B minus A also. Okay, C is greater than B. So A minus B or B minus A, I am taking a mod. Okay, negative value has no meaning in the measure of length of a line. Okay, so mod. So C is greater than A minus B. That is A minus B is less than C. Okay, so I can write A minus B is less than C is less than A plus B. So this is called the triangle inequality. So now we come to axioms. Axiom 7.1, that is chapter 7, 7.1 in your chapter 7. Side angle side congruence rule. So this is an axiom. So we start with first one axiom. Okay, that is two triangles are congruent if two sides and the included angle, if two sides and the included angle are equal, the two side and the included angle of the other triangle, then they are congruent. That is, if this is two side and this angle, and if there is two side, this A2, B2, or A1 is equal to A2 and B2 is equal to say C1, and this theta 1 equal to theta 2. So this is your side, this is angle, side. If they are same, then it is a congruent. Okay. Now theorems. This is axioms. I have assumed this. Okay. Now I can use this axiom to prove other congruence rule. Okay, and we will see this. Two triangles are congruent if two angles and the included side, this is the included side between the two angles, this is the included side of one triangle is equal to two angles and the included side of the other triangle. That is side 1 equal to side 2 and alpha 1 is equal to alpha 2 and beta 1 equal to beta 2, which I have written. Okay, then we will also see, and we have also can guess that if two angles are same, then the opposite, because this side is fixed, the opposite side will be of equal length. Okay, then I can again use this side angle side criteria, that axiom, and this also side angle side, because I am saying that if two angles are same, the opposite side will be same. So side angle side and side. So by side angle side I can prove angle side angle congruence rule. Okay, similarly we can use either this theorem which we have proved or this axioms, and similarly we can prove side angle side we have taken as axioms, and right angle hypotenuse side congruent rule. We will see them in next pages. Theorem 7.2. Angles opposite to equal side of an isosceles triangles are equal. What do you mean by isosceles? Two sides are equal. So if these two sides are equal, this angle and this angle has to be equal. This is the opposite angle of this side, this is the opposite angle of this side. So what we have to prove, that angle B, this angle B is equal to angle C. What is been given? Given that it is an isosceles triangle, AB is equal to AC. Now I bisect this angle. So this angle is equal to this angle small. That is angle BAD is equal to angle CAD. Okay, this is by construction. I divide by hand. And this is a common. AD is common. So then from side angle side, this is side, this is angle, this is side. So using side angle side rule, triangle BAD is congruent to triangle CAD. And since they are congruent, this triangle is congruent to this triangle. This is using corresponding part of congruent triangle. I will define what Cpct is. This is a short notation of corresponding part of congruent triangle. So this angle B, because they are congruent, this angle will be equal to this angle, and congruent, all the angles has to be same. This angle is equal to this angle is this. So that is angle B is equal to. Additionally, some other information, that triangle BAD, this triangle BAD is congruent to CAD, implies that BD is equal to DC, because they are congruent. And also angle ADB, this is ADB, is equal to BDC, because you know this is a straight line, and this angle is equal to this angle because they are congruent. So twice of this angle is 180 degree, so this angle has to be 90 degree. So they are perpendicular. Now theorem 7.3, the side opposite to equal angles of a triangle are equal. So side opposite to equal angle, suppose this angle and this angle is same, so side opposite to this angle, this length and this length also will be, the sides will be same. Right? This is for a big triangle, this is for the small triangle. So again, using either ASA rule, angle side angle rule, or side angle side rule, again I can use either this side angle side, okay, or this is side, like what we did earlier. We can show that, and we have already shown that triangle ABD is equal to triangle ACD. So AB is equal to AC for if these two angles are same, this opposite So it's a vice versa of the previous one. This is a vice versa of this. Okay, angle opposite to equal side of a isosceles triangle are equal, and here the sides opposite to equal angles of a triangles are equal. And this becomes isosceles. Theorem 7.4. This is side congruence rule. If three sides of one triangle is equal to the three sides of the another triangle, then the two triangles are congruent. So here just to just teach you all how to construct a triangle for a given equal length sides. Okay, suppose I make an arc here of this length, and I again make an arc here with, then these two lengths will be same because I am using compass and making it. Okay, and I go to this point B and I make an arc here of this length. So I will have this length and this length. Again I draw arc here. I will have this length and this length. So if suppose this side, there are three different lengths. This is side, this is another side, this is the third side. So these two triangle 1, I label it as triangle 1 and this is triangle 2. So this looks like a mirror image. Triangle 1 and 2 are mirror image. So this angle will be equal to this angle will be equal to this angle. This is a common side. So again I can use either angle, side, angle or side, angle, side. Prove that these two triangles are congruent. Note, from angle, one may get only similar triangle, which I had said. But these angles are same, but the length can be different, which I have said. But three sides equal and three angles equal, only they are congruent. Okay, this you have to remember. Just simply angle is same doesn't mean it is congruent. It's similar. And RHS congruence rule, theorem 7.5, it says if in two triangles the hypotenuse of one triangle is equal to the other hypotenuse of the other triangle, and one side of each triangles are equal, then the two triangles are congruent. What I mean to say is that if hypotenuse of one triangle is equal to the hypotenuse of the other triangle, this is triangle AOB and this is triangle A prime OB prime, and hypotenuse are equal and one of the side, say OB is equal to OB prime, then they are congruent. So we will prove here. So before going to the proof, I will give an example. That suppose this is a wall and this is the floor, and you are given a stick of length, say fixed length of AB. Now I can place like this with some angle, or I can place like this with another angle. This angle and this angle will not be same, of course. The slopes are different, so angles are different. But if you are given a condition that I have given you one stick, but one of the side has to be, either height has to be fixed or the base has to be fixed, then you cannot do, there is only one way, that is to keep what way, if the base is fixed, it's fixed, so this stick has to be placed here. Okay, so this is what it is saying, that if hypotenuse are same, if these are same and also base are same, then they will, this triangle, they are congruent, they will overlap. Okay, so if either OB is equal to OB prime or OA is equal to OA prime, one of the condition, one side, it says one side. Okay, so here you see, here I have drawn here much in a more elaborately. So this hypotenuse is this is that stick AB, and this is a fixed, this side is equal to this side, and the hypotenuse is given only one stick. Okay, so this angle will always be equal to this angle because they are overlapping. So from this side, angle, side, okay, triangle AOB is congruent to A prime OB prime. Now before finishing this congruence rule and theorem, now what about side angle? Suppose this side is given to you, then next this is a side connected to one side is given and this angle. So if the side angle of two triangles are same, then will it be congruent? So it can only be congruent for two cases, but if for one case it is not, so it is not a general rule. Okay, so here is the proof. Suppose you have this, this is the angle subtended and BC some ray here, suppose this line, and this is angle theta. Okay, this is acute less than 90 degree, and you are given a stick here. Okay, you can place the stick either like this, or you can place the stick either like this. So in this case, this triangle, that BAC, and this triangle BA, say this here D or something, they will not be same. They are different, because you can place the stick in two different this side and angle. So side angle for theta less than 90, it will not hold. Congruency will not hold. But if you have obtuse angle, you will see that there is only one way. Suppose you have been given this stick, there is only one way you can keep it for obtuse. Similarly for 90 degree also, as we saw about, only one way. So for this side angle or angle side will hold only for theta greater than 90 or equal to 90. So if you want to use this side angle, then in bracket you have to write for 90 degree or for obtuse. You can use it, but it is not valid for acute angle. Acute angle, you will not get two congruent triangle using this congruence rule. Okay, now theorem 7.6 and theorem 7.7 of your textbook. This is very similar. It says that if two sides of a triangle are unequal, the angle opposite to the longer side is larger. The angle will be larger opposite to the longer side. And theorem 7.7 says in any triangle, the side opposite to the larger angle is longer. Okay, what it means, that suppose this is a larger side, AB is a larger side, this angle B is the largest. Angle B is greater than angle A and angle C. This is for the obtuse. For an acute also, suppose this is a larger, so this angle A will be greater than angle B and angle C. This is what I have written. Or vice versa. What does vice versa means? It's same thing, like if this is a larger side, this angle will be larger. Or if this angle is larger, then this side will also be the larger. So now we prove theorem 7.6 and 7.7. For this, we draw a triangle ABC. Okay, from point A, this is from point A. I take AC, this measure by compass, and draw here same length. This length and this length is same at point P, and draw a straight line here. So I get an isosceles triangle. So if I get an isosceles triangle, then this angle and this angle is same. Angle opposite to equal sides are same. That we have studied. So if I call this X, the remaining I can call it Y. And if this is X, then this is 180 minus angle X. This is the remaining part is a straight line. This angle plus this angle should be 180. So this angle will be 180 minus X. Now we consider this, and from triangle BPC, then I know that the sum of the angle B plus this angle 80 minus LX plus Y, okay, should be 180 degree. So here I am writing angle B plus 180 degree minus angle X plus angle Y is 180. So I cancel 180 degree and 180 degree in both the sides. These are plus sign, and this minus LX will go to the right hand side, will become plus LX, and this will also go in the right hand side. So LB is equal to LX minus LY, but LC is equal to LX plus LY. So this angle C will be greater than angle B, because this X plus Y will always be greater than X minus Y. So angle C is greater than angle B. This is for theorem 7.6. But we have to also prove that angle C is greater than angle A, which we will prove it below. Okay. So for theorem 7.7, because AP is equal to AC, AB is AP plus PB, but I am writing AP is equal to AC. So I substitute AP equal to AC here. So AB is equal to AC plus PB. Okay. So AB, this is an additional term. So definitely AB will be greater than AC. Okay. So this AB is greater than AC. Okay. And we have to show that AB is also greater than BC. Okay. And angle C is greater than angle A. This also we have to show. So now we, instead of now point A, we take point B here, and again Since this is the longest part, I can, and this side I can again using a compass measure this and draw here point P and draw an isosceles triangle. And again I label this as angle X and this as angle 180 minus LX. Okay. And angle C is again X plus Y. Okay. This is angle X and this is the remaining part is Y. So from point B now we have done. Draw BP is equal to BC. So we have drawn BP is equal to BC. So it's an isosceles triangle. And angle C is angle X plus Y. Okay. Here it is angle C is angle X plus Y like above. So for triangle, now I consider this triangle, APC triangle. Here I made isosceles this one and I consider this triangle. Now below part I make it isosceles and consider this triangle. So for triangle APC, okay, again same thing, angle A plus angle Y plus angle 180 degree minus angle X. This is 180 degree minus X. So I again write here angle A plus angle Y plus 180 degree minus LX is 180. Sum of all the internal angle of a triangle is 180. So here again 180, 180 cancel. I get angle A is equal to LX minus LY. Okay. So similarly, angle C is LX plus LY. X plus Y is always greater than X minus Y. So this is for Theorem 7.6. This is angle C is greater. We proved earlier angle C is greater than B. Now we have proved angle C is greater than angle A. Okay. Now we have to prove for Theorem 7.7 this BP is equal to BC. So AB is equal to BP plus PA. But BP is BC. Here I have drawn it. Okay, I have taken it isosceles. So BC plus PA. So definitely then AB is greater than BC also. So from 1 and 2, we find that angle C is greater than angle B and angle A. So if LC is greater than LB and LA, then the opposite side of LC, that is line AB, is always greater than AC and BC. That's what we proved. Okay. Theorem 7.8. The sum of any two sides of a triangle is greater than the third side. That we have proved. So to prove congruency, you need to show the congruency between the corresponding sides and the corresponding angles of the two congruent triangles. It is called corresponding part of congruent triangle or Cpct, which I have mentioned earlier also. So now let us summarize what we have studied. Congruent triangles. This is called the corresponding part of congruent triangle, Cpct. Okay. What does Cpct says? That these corresponding parts have to be same. Say this is one part, this is the another part of the another triangle. If this part and this part, okay, this part, this one more, and this is same, and this C is also same as F, and angles are also equal. Angle 1 is equal to angle 5, angle 2 is equal to angle 6, the corresponding angle. I have just rotated to confuse you all, but it is sometime you can have two different triangles in two different places and they may be rotated, so you have to know whether they are congruent or not. So that's why I have done that. And angle 3 is equal to angle 4. Okay. Because this is, as I said, this is angle opposite to congruent sides. So this angle C, okay, this is side C, this is angle 1. So angle 1, this is 3 dash, opposite angle is 5. This 3 dash opposite angle is, so angle 1 is equal to angle 5. 2 dash, opposite angle is 3. 2 dash, opposite angle is 4. So angle 3 is 4. Similarly, A and this is D. So opposite angle is 2 and angle is. So this is what I have written. These are the congruent rules: side, 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 side angle, side, angle, side, angle, and angle, angle, side, and right angle. For right angle triangle, hypotenuse and one side. If they are same or both the triangles, then they are congruent. Similar triangles, angles will be similar, the corresponding angle, but not the corresponding sides. Okay, they are in some constant. Okay, a is some constant times d. A is not equal to d. This a is not equal to d. B is not equal to e. There will be some constant time e. So they are similar. Okay, the angles may be same, but sizes will be one small, one big. For a right angle triangle, if the hypotenuse and one of the side is same of the two triangles, then they are again congruent. And we also saw that suppose if your C is greater than B is greater than A, then this angle C, opposite angle is a C1. So C1 will be greater than angle B1, will be greater than angle A1. We also saw that if you have an isosceles triangle, if A equal to B, isosceles, then angle A1 is equal to angle B1. Okay, the opposite and same side equal same length, so opposite angle will all be also of equal measure. Okay, angle A1 is equal. And for an equilateral triangle, if all the sides are same, the angles will be same, and this angle, sum of all the internal angle is 180, and angle, since they are same, this will be 60 degree. Thank you for listening. So see you in next lecture.